So today we're talking about harmonic motion, and we've already done a lot of this a couple units ago when we were graphing like sine and cosine functions. So it should be pretty familiar. Your formulas have a little bit of like different letters in there. We were used to having like A, B, C, and D, and they didn't put those in there this time, but we'll still do that when we need to. There's a bunch of vocabulary for you up here. So if it's talking about a cycle, that's like the same thing as your period, which I think we talked about that a couple units ago, so that's just how long it takes to like start repeating. What else is important? Amplitude, we already know what that is. That's like how far up you go or how far down you go. Then it gives you your formula for period right here. And the new thing that we haven't talked about yet is frequency. So that's like the number of cycles that you go through per your unit of time. So we'll have to use that to solve a little bit later. So what's going to be a little bit tricky for some of these is you have to decide whether you're going to model with a sine function or a cosine function. And so that just kind of depends on if you start up or if you start at 0. So do y'all remember like when we were doing the Ferris wheel? We started in the middle, so we said that was like at 0, so you used your sine function. For some of the ones that we're doing today, it's talking about like a spring, so you pull it down, so you're already starting down instead of at 0, so that would be a cosine instead. Does that make any sense? Maybe. So that's what this is talking about. Yeah, y'all go. Are we good to go ahead and try one? Okay, cool. So let's do that. So we've got an object attached to a coiled spring, and it's pulled down at a distance of 5 inches from its rest position. So the fact that it's being pulled down first tells us that your A value or your amplitude is going to be negative, right? So I'm going to say A is negative. Then it's at a distance of 5 inches. So that's your displacement, which is basically just telling you that your amplitude is 5 or negative 5 when we go to write our equation, since it's being pulled down to start. Distance of 5 inches, and then release. So the time for one oscillation, so that's like one cycle, is 3 seconds. Develop a model that relates the displacement d of the object from its rest position after t, or time t in seconds. So basically just write an equation for the situation. Assume no friction. Also find the amplitude, period, and frequency of the motion of the mass. Sketch the graph of the displacement of the mass. So let's go ahead and write the function first. So we're going to have y equals. Now since we're starting with it like pulling it down and then releasing it, it's not going to start at 0, but it's going to start at like your amplitude, so that's a cosine, right? And we said it's being pulled down, so it's got to be negative, and it's going down 5 inches, so that's like a negative 5 cosine. So we're using, which formula? This one. A cosine WT. So our function is going to be like y equals negative 5 cosine. Then we have to find that W value. So if you look back up at the top, that's coming from your period or your frequency, which is your time to complete one cycle. So we know that, how long does it take? It tells us it takes 3 seconds for one oscillation. So the way that you would set that up is like, how would we set that up? So 2 pi over W, whatever that is going to take 3 seconds. So then you solve for W, so multiply by 3, divide by W, whatever, or multiply by W. So that's going to be 2 pi over 3 is that W value. So that's going to go in right here. 2 pi over 3t. And that's all that we would put for that. What else do we need? That's our equation. We need to find the period, which was just 3. That's what we put over here. So we'll put that period equals 3. Amplitude, we could write that as well. Your amplitude is 5. That was from them pulling down 5 inches. It wanted us to find the frequency. So the frequency, if you look back up at the top, it's just like the reciprocal of your period. So instead of 2 pi over 3, what would our frequency be? Flip this guy, so it'd be 3 over 2 pi. So that's how many cycles are happening per unit of time, so like per second. And the last thing it wants us to do there is graph that. So we're going to kind of use this picture that we have over here to just build off of that. So we've got like your height and stuff over here. So I'm just going to make this like our axis at 0. And then I'm going to redraw our time over here, or height. So we'll have like -5 and +5. So again, we're starting at -5, right? So that'll be down here. And to complete a whole cycle, it's going to take how long? 3 seconds. So we know, do y'all remember how like when we were doing the Ferris wheel, we split it up into 4 chunks? So you had like your low point, your middle point, your high point, your middle point again, and then you repeat over and over. So we're going to do that still, so you'll have 4 chunks, 3, 4, and the 4th chunk is going to be at 3 seconds. So then we're just filling in the dots from there, so plotting those points, we'll be up at 5, and down, and then back down. And my graph is really ugly, sorry. And we're going to keep going. And that's basically all we have to do there. Is that okay? So again, most of the stuff we've done before, we just kind of have different words for it now and like different ways of writing it, but nothing super new there. Questions? All right. Frequency is up here.
Well, yeah, but like,
So
final, would it be times
oh, I see what you're saying. So if we did 2 pi over 3 over 2 pi, is that what you were talking about? Sorry. So then that'd be like 2 pi over 3 times 2 pi. Or no. Yeah, 2 pi over 1. So like 4 pi squared over 3? Is that technically what that should be? You just say Let's just not worry about that. We're just not going to do it. I don't think you have to know that in this class. I think that's more of a physics thing. Okay, but like when I was looking up here, I think because I just flipped W, I didn't flip the period, so that was my fault, so I did that wrong. So we're just not going to do frequency. But again, I don't think you have to know that for this class. We'll do it on the next one. Is that okay? So look at the next one. Suppose that displacement d in meters of an object at time t in seconds satisfies this equation right here. So describe the motion of the object. Basically, if you've got like a trig function in there like that, it's going to be harmonic motion. So it would be harmonic motion. I'll write that. Simple harmonic motion. The next part wants to know what's the maximum displacement from its resting position. So how would we find that? Yeah, it's 10, it's your amplitude, right? So it would be 10 in either way. Say max displacement is your amplitude, which was 10. Max displacement, I just abbreviated it. The next part wants to know the time required of an oscillation. So that comes from this W value that they've got in there, 5. So we had last time, how did we write it? We said that W equals 2 pi over whatever that time was. So we have to find that time value this time. So we'll have 5 equals 2 pi over your period, whatever the period was. And so you'd have to solve for your period there. So that's just going to be 2 pi over 5. And that's seconds per cycle. So then part D there, that one wants our frequency. So we're going to do W over 2 pi. And our W value, they gave it to us in the beginning, was 5, so it's just 5 over 2 pi. And that's cycles per second instead of seconds per cycle. And that's it. Is that okay? Questions or anything? Okay. So the last part we have is a Ferris wheel problem. So we've done a ton of these, so this one should be fairly simple too. So it says a person is seated on a Ferris wheel of radius 100 feet that makes one rotation every 30 seconds. The center of the wheel is 105 feet above the ground. Find and graph a function to represent the person's height above the ground at any time t of a 2-minute ride. Assume uniform speed from the beginning to the end of the ride and that the person is at the level of the center of the wheel and headed up when the ride begins. It wants us to make a table and stuff, but I really don't think that we need that because we know how these work fairly well, I think. So we know that the center of the wheel is 105 feet up, right? So do y'all remember what we do with that information? Do it. We could, yeah. So if we're talking about the graph though, do you remember what we did with that? It's like your zero, it's like your middle, that midline. Do you remember doing that? We did the dotted line at whatever the center was. That's what we want to do here too. So let's see.
Center of the Ferris wheel?
It's going to be like the center of our graph, like the midline of our graph. So, but yes, the center of the Ferris wheel. Yes, sorry. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. So let's do 1, 2, 3, 4 is 100. So 105 is going to be just barely above that for the center of our Ferris wheel here. And we know that, again, it's going to take like every 4 chunks, it'll do 30 seconds. Does y'all remember doing that? So we took however long the cycle is around and divided it by 4. That's not going to come out evenly, but can we just do every 4 ticks, make that a 30? Is that okay with y'all? So 1, 2, 3, 4, that's 30 seconds. 1, 2, 3, 4, 60 seconds. 2, 3, 4 is 90 seconds. 2, 3, 4 is 120 seconds, and that would be our 2 minutes. So that's as far as we need to go there. What else does it tell us? The radius is 100 feet, so that means that you're either going to go like up 100 feet or down 100 feet, right? So let's see, if this is 100, then 200 would be about up here. When we start, we're starting at 105, right? And then in your next chunk, you're going to go up 100 feet. And then the chunk after that, you would be down at the center again. And then the chunk after that, you would be down at the bottom. Do y'all remember that? Yeah, so that's all we're doing here. So just sketch that in. Is it supposed to look like this? What you mean? It's supposed to be every tick mark in between the 30. Do you have questions on that? It's 100. I have it just barely above 100, so it should be at like 105. But because our graph is so small, you can't really tell it, but it should be at 105. So I had marked that tick line as 100, but this would be at 105. Does that make sense? So we have our graph. Any other questions on the graph? Are we okay with that? So we need to write our equation. So we need a period, we need an amplitude. So our period is like one rotation. And how long did it take for that to happen? 30 seconds. Your amplitude is like your radius, right? And what was that? 100 feet. Okay. And then what else do I say? Huh? Okay. I mean, first ones aren't like super slow. They're like kind of slow, but not like super slow. Radius, amplitude, radius 100 feet. What do we still need? Oh, to do our period, we'll say our period equals 2 pi over w, and that was 30. So if we solve for w there, it's going to be 2 pi over 30 equals w, and then that's going to be pi over 15 for our w value, which is just what we're going to put into our equation when we go write that. So we're going to have y equals. And then our amplitude was 100, so that's our a value that goes out front. And was this one a sine or a cosine? Did we start at 0 or at an amplitude? We started at 0, so that would be a sine. And then our w value was pi over 15, so that's inside pi over 15w. And then our midline was at 105, so how do we handle that? Do you remember? Yes, it's supposed to be t. That should be a t, not a w. Plus 105. And that's it. That's all we have to do on that one. Is that okay? Questions? Yeah. Okay.
None.